My name is Abijos. Welcome to the peer graded assignment course project, which is submitted as part of the Coursera course, AI for Product Management Specialization. Let's start with the problem statement. The problem statement is to build a model to predict the electrical energy output of a combined cycle power plant. Here we could see that there are uh, 5 variables which is captured. Out of that, 4 are independent variables, and the final one is target variable. The independent variables are temperature, ambient pressure, relative humidity, and exhaust vacuum. And the target variable, which is supposed to be predicted, is the net hourly electrical energy output, called PE. And for the project, so there is a data set which is given. So there is a large amount of data. So this could be utilized for training and test the model. As we can see that as the first impression, the input variables or the independent variables are continuous in nature. Because of that, it's decided to use the regression models, basically the linear regression models. So that's the initial impression. So the models used are regression models here. Let's move on to the objectives of the approach, starting with the modeling approach. In the modeling approach, so we will be identifying the type of modeling task, various features to be used, and then identifying the possible algorithms to use. So that is the approach of that. Second objective is model building. In model building, we'll try to compare with different algorithms which you have chosen in step one. And then we will also try to go for different combinations of the features. In addition, so we also try to identify what kind of an approach we use. Is it a validation approach, or is it like a standard train and test approach, or to use for a cross validation approach? So we will be defining and confirming that part over there. During the model evaluation step, it speak about the evaluation matrices, basically to determine the performances of the model and also to calculate it on the set. So that could be that. So we could compare the performances of various models and see which model is the best fit for this given problem statement. Model interpretation is the final objective. Here we could able to interpret and clearly communicate the performance of the model, the reasons for selecting the models, and how exactly the models work. So basically we are trying to interpret over there. Let's start. Since the variables are continuous in nature, so decided to go ahead with the regression models. To understand the statistical significance of each of the features here, I have started with a simple regression where one feature is selected in one particular step to understand how these each variables are correlated to the output, the predicted output. So starting with the first feature, AT. Uh, Here, we actually went ahead with the standard train and test approach. 80% was selected for train and 20% was selected for test. Python data libraries were used here to build and execute the model. Here you could see that the first feature, AT, which was tested against PE, which is the target variable. You could see that the model evaluation was pretty good. The R squared value, the coefficient of determination is pretty good here. Got a result of 0.90. The mean absolute error and yeah, the mean square error and root mean square error, the values are here. This is okay, comparatively good. Then if you compare with the simple regression for other features, like let's say the second approach, it was feature V. And then the model performance was not that great. It was degraded compared to the feature 80. Continue like that, so we could see that the last feature was RH, where RH is not that statistically significant for this given problem. The R squared value is very, very less here. Having this in hand, we decided like since there are four variables and these variables are independent in nature, it's always good to have combination. So that means we have to go for multiple regression. So three cases were identified here. In first case, all the four features were selected. Again, went ahead with the standard train and test approach, 80 and 20%. The model evaluation, the model performance was really good. The coefficient of determination square came as 0.932, which is pretty good. The mean absolute error is 3.562. Mean square error is 19.286. Root mean square error is 4.392, which is pretty good. And then also we understood that from the simple regression, the variable RH significance, which is very less significant. So try to avoid that, and then went ahead with the three features. The model performance is still good, though it is a little bit reduced, degraded, but it's still good. In case three, so we try to eliminate the further less significant features and executed it. Okay. So this is the summary of multiple regression. So further, so I have decided to execute the model with a ridge regression by applying a ridge regression model. Uh, Again, here instead of the test and train and test model, so decided to go for a cross validation model. Here, the k-force cross validation was identified. Went for a fold of 10 and repeat of 3. And then there were two cases which was identified or validated. In first case, it was all the features were identified and then executed. So the model evaluation is actually comparable with the multiple regression. So the R squared value came as 0.928, and similarly the other evaluation matrices also. In case two, so the less significant RH was eliminated and then executed against with the other parameters. The R squared value came as 0.918 and the other evaluation matrices also. Let's compare between multiple regression and rigid regression here. We could see that the output is almost identical or almost comparable for both multiple regression and rigid regression. When we select all the features, all the four features, we could see that multiple regression is having a slight advantage. The performance of multiple regression is a little better. The coefficient of determination is 0.932 for multiple regression, whereas the rigid regression came up with 0.928. But if you optimize it further by eliminating the less significant relative humidity variable feature here, then we could see that rigid regression is having a slight upper hand or slight better performance. The coefficient of determination of rigid regression came as 0.918 in that case, whereas the multiple regression, the R squared value of multiple regression is 0.916. That's all about the experiment. To conclude, to summary and conclude, the given variables were continuous in nature, hence decided to opt for the regression models, linear regression models. Multiple regression models and ridge regression models are compared. These were the two models taken for comparisons. The performance of the models were almost identical. That's how it was observed. The optimum performance was observed when considered all the given features, even though the variable relative humidity was very, very less significant, but then the best performance was when considering all the given features. Also, if you see the approaches of standard train and test and then cross validation, you could not find much significant differences between these two approaches. The performance and output were almost similar, even if you selected standard train test approach or cross validation approach for this particular problem statement. Probably, if you go for a bigger data model, there could be some significant differences, but at least for the given data set and given problem, so could not find much difference. That's all about the project. Thanks a lot, everyone.